Bump. Okay. So, and I tell you, it's normally distributed. If I ask you questions about a percentage of data is where, what's going to take over? What
Empirical
rule comes into play, right? So what we should do is we should put the mean in the middle, that's where it goes, and then I can start counting up and down so many, right?
Right.
So if I add one step, that'll be 14.77. If I add another step, that'll be 17.17. No, 24? I don't know. So we can double check it. If I subtract this step, that'll be 9.83. Frickin' hell. If I subtract another one, that'll be 7.36. That sounds about right. Okay. So if I said what percentage is between 7.36 and 17.24, what would you say?
2 steps out.
2 steps out, so therefore
95%.
95%. Yeah. Why? Empirical. Yeah.
I don't know what happened. I got possessed. I put 96.
No, you're fine. I'm not coming down on you. That's pretty close. You guys kind of with me? So you can always, if I give you a mean, standard deviation, and say it's normal, you can always do this. Will it always be useful? No. Can you always do it? Yeah. But if I ask you a question right now about percentages, that's the only thing we know that tells me any percentages of data anywhere is the empirical rule.
You could trick us and not use the word normal, and we got to use Chebyshev, right?
Well, again, I'm not going to ask you a question about Chevy. I just want you to know Chevy exists. I want to give him props. So he's not sitting out there in a cabin doing all this work and nobody ever talks about him. But I'm not going to do Chevy too much with stuff. Yeah. It's out there. Anything else? That was a question I asked myself, basically, so I can share that with you. Okay.
Yeah. These are questions about the quiz, right?
Yeah.
The latter half of it dealt entirely with populations because we were given the population variables, so the denominator should have been the total size.
Number 2, there's no, you don't have to calculate standard deviation, they just tell it to you.
Oh, okay, good.
Yeah.
I don't know why I'm thinking about that for a
I
second.
don't know.
I'm like, did I do 11 or 12?
Oh, for number 1.
No, for number 1 it matters.
Number 1 is the sample,
For number 2 and 3.
for damn sure. So you better pick S squared, not sigma squared, because number 1 was the sample.
Oh, but I meant for the
How could
denominator.
you tell?
The one's going to be n minus 1.
Because it says it was a sample. Yeah. Even though it didn't say it was a sample, I didn't say it was a population, so therefore it's a sample. Yeah. Alright guys, so you'll be able to make corrections on that if you need to?
Yep.
Alright. Okay. Alright. I'm a math teacher, I'm used to bumming people out, and you guys look bummed out.
All of the correction is due next test.
Say again? Oh yeah, corrections are always due the day of the next test. So a week from today we have a double quiz, not a test. So nothing's really due that day. You should get as much of chapter 3 done, obviously, because it's a quiz about chapter 3. So let's review what we did last time. I want to show you a couple of other things that you'll need to know, and then I've got this worksheet. I'm gonna put you into groups so you actually talk to people, and we'll see how it goes.
We can turn in corrections earlier if we want to, right?
Say what?
We can turn corrections in earlier if we want to.
Hell yeah. Yeah, early is good for any damn thing. Late is not good for anything. So, can somebody tell me one thing we learned last time?
We learned and or and the differences between how
Alright.
we have to
Somebody else tell me another two. We got and or, and how they relate to probability questions. Yeah.
We learned how to check if something is independent.
Sweet! We learned to check if something's in it. How does that relate to what Shella just said?
What
Given.
did he just say?
He said given.
Oh, because if you have like probability A given B, your probability will equal A and then vice versa. Vice versa.
Probably A given B.
Will equal probability A.
Good, will equal probability. So if A and B are independent, then does it make sense that, let's see, I got little droplets of ink, I love it. I'm not sure what to do with it. If A and B are independent, that means that if B happens, A doesn't care. So what's the probability of A, given that B happened, if they are independent? Yeah, it doesn't change. There are 3 problems. I think they're 43, 44, 45 in the homework. The very first sentence is the most important sentence in each one of those. One of them says these two are independent, another one says they're mutually exclusive, and I think the third one says independent again. And people just kind of go past those. And those are the most important. How much have I talked about mutually exclusive so far? I can't remember.
0.
Oh, that's awesome, Jeff. Okay, so let's talk about that.
It just means independent, because when you're mutually
So,
exclusive.
real quick, how many days have we lectured on probability?
1.
One, good. There's a lot to get out there. So I appreciate you helping me remember what I haven't talked about yet. There's a lot. Independent we definitely talked about, because that one normally freaks people out. Mutual exclusive is very straightforward. When I say exclusive, what do you think?
Isolated.
Isolated?
Not having to do with
Separate or special.
the relation.
I always think of like a club that would not let me in, right? They're exclusive. You guys kind of with me? Yeah, specifically me. Okay. So exclusive. If they are mutually exclusive, they're like, you can't be here and you can't be here either, right? So it's like if somebody didn't let me in, I'm like, I don't want to be in there anyway. So mutually exclusive things would be like a rock and ice cream. Yes?
What's the difference between that and independent?
Oh, so much. Let's talk about just this for a minute. Can you be a rock and ice cream at the same time? And I don't mean ice cream that looks like a rock.
No.
And I don't mean a rock that looks like an ice cream cone. I mean, can you physically be a rock and ice cream at the same time? Okay. So that would be an example of mutually exclusive. The probability that something is a rock and ice cream is 0. So what does it mean when I say two things are mutually exclusive? The probably one and the other is 0. There's no chance. So if I have a normal deck of cards, what's the probability I pick a card that is red and black?
0.
0. Right? Or if I said hearts and clubs, 0, right? And if it's not 0, I ain't playing shit with you and you're a weird ass deck, right? But turn it this way, it's an ace of clubs. Yeah. Always get royal and get out. You guys semi with me?
My gosh, sorry.
What happened? All right. Okay. So that's, now what's the difference, real quick? The most dependent you can be is if you were mutually exclusive with somebody else. Let me show you why. Do you agree that rocks and ice cream are mutually exclusive?
Yeah.
Okay, so let's say you go into a room and you're blindfolded, and there's 5 bowls of rocks and 5 bowls of ice cream. Right. And you pick one up. What's the probability I picked up a bowl of ice cream?
1/2.
1/2. Is everybody cool?
Yeah.
5 out of 10, right? I take off my blindfold, or I bite into it. It's a rock. It's rocks. What is the probability, given that it is rocks, what's the probability now that it's ice cream? 0. So if they are mutually exclusive, they are the most dependent, because if it's one thing, it cannot be the other. Do you understand? So what does independent mean? One thing happens and it does not affect the probability of the other. So if given that it is rocks in the bowl, what's the probability it's ice cream? 0. What did the probability of ice cream, what was it before? 50%, right? There's a 50% chance I picked up a bowl with ice cream. You all said it. You all agreed? Nobody went freaky? Yes?
So that relationship then, sorry, I was thinking I was onto it, but the act of it not being ice cream makes it absolute. So
Makes it impossible for it to be ice cream.
But
Yeah.
then, how does the dependent play into that?
So to maybe be independent, you cannot be mutually exclusive. So real quick, here is a picture of two things that are mutually exclusive. We don't really use Venn diagrams the way I teach, but have you ever seen a Venn diagram before? So this is rocks and ice cream. Why are they mutually exclusive? Visually.
No overlap.
No overlap.
Yeah, but doesn't that mean they're
So,
independent? They're separate.
given that rocks happened, is there any chance ice cream can happen at the same time?
No.
Nope. But if I have two things that are not mutually exclusive, what's going to happen now if they're not mutually exclusive? Like jacks and blackbirds, right? You guys all with me?
Mhm.
Given that a jack happened, is there a chance it could be black?
Yes.
Yes. So therefore, there's a chance it could be independent. And again, the giveaway is what is the top of the given formula? What's on the top? and B.
Divided
Yeah.
by probability of B.
And if they are mutually exclusive, what is that always?
0.
0. I need you.
You can't divide by 0.
Probability of
Well,
A.
no, this,
Oh,
not,
0
this is
over.
0, this is 0.
Yeah.
Right? If they're mutually exclusive, the probability they both happen at the same time has to be 0. That's what it means to be they mutually exclude each other. You can't be both, so it's probably that you get both, 0. So whatever the hell probably this was, will always go to 0.
Are all mutually exclusive things
Dependent. Yes.
I'm confused about that because visually they're clearly separate. It
I
looks
know,
independent
exactly.
to me. They're not.
I know. That's why I don't teach using this too often, and that's why right now I'm saying maybe I shouldn't have done this. This is not independent because what does it mean to be independent? If one happens, the probability of the other one doesn't change. But here, look, the fact that they are separate means this. If this guy happens, he's got no chance. Whatever the chances of this was before, it is now 0.
I see.
That is the most dependent you can be. Not only does the probability change, it goes to nothing. You ain't got a chance.
It's the probability.
Okay, maybe. I don't want to spend too much time on that. That's a very little freaky little thing about how they interact. But be careful. One does not mean the other one. In fact, in this instance, if it's this, it means it's not this. All right. And then, it's the other way around, actually. Okay. So don't let those go together. Just consider them separately. Okay. So if there's a question in the homework that says, are A and B mutually exclusive? Well, did you calculate the probability of A and B? Was it 0? That's it. That's all you got to see. If the probability of A and B is 0, they're mutually exclusive. Okay. All right. Moving on. There's not going to be any problems that really kind of merge those together, but when the question comes up, I want to show you. Okay. It's not a big problem, not a big part of it. Stay with me. I did change you up. So the other things we got were the probability of A or B. What's that basically? Or is basically what?
Addition.
Oh,
Add. I love it. Or is basically add. Why do I say basically? Because not only do you add them together, you have an adjustment to make sometimes.
probability of A and B.
Notice if they were mutually exclusive, what would this be?
0.
In the event that they're mutually exclusive, you can just add them together. You guys see that?
Because you'd be subtracting nothing.
Because you're subtracting nothing. Exactly. Is everybody with me?
Yeah.
What's probably an A and B?
Multiplication.
Yeah.
Probability of A equals probability of B given A, or A given B.
A, B given A.
B given A.
Or the probability of B
Or
times the probability of A given B. So if they were independent, wouldn't those two just be that? Independent means that happened and this doesn't care, yes?
Yep.
So then it is just a straight up multiplication only if they are independent. So these adjustments are in case they're not independent or they're not mutually exclusive. There's an adjustment. Okay. You guys semi with me. And again, just to remind you guys, probability is not hardwired in our brain. It's not supposed to come to us like that. A lot of it's very counterintuitive. It just is. Why? Because our intuition sucks in some cases. It's molded by evolution. We had no reason to know some of this shit. But we got to a point where like, what is this shit? Oh yeah. And then we talk about it. Okay. Maybe. That's the drunk history of evolution and math. Okay. I'm not drunk, you are. So, one last thing here, and it kind of comes, it's actually where we got this from. What's the last formula that's missing from up here?
Probability of A given B.
A given B? Yeah. And that one I just had up here a minute ago.
Probability A and B divided by the probability of A.
Kick ass. Okay.
I think it's supposed to be B. If
B.
you're doing A given B, it's B. But if it's B given A, then it's A.
Thank you. Now, if I gave us an example problem, let's see how we do from what we did last time. So let's say I've got 11 11 watermelon seeds, 7 what else can you plant? I don't know. Strawberry seeds. Yeah, I like it. And 8 cucumber seeds. I like it. Whisk. Y'all with me?
What's
Doesn't-
this?
huh?
What's this?
Strawberry seeds. Yeah. I grew strawberries when I had a garden. Some of them even got this big. It's crazy. So if I reach in and grab 2 seeds without replacement, right? What is the probability that I get a watermelon seed and a cucumber seed? So remember how to set this up. How many choices am I making? How many picks am I making?
2.
2. 1, 2 times and. What's probably the first seed is watermelon seed.
So 11 over 20?
11 out of
26.
26.
26.
Very with that, you guys cool? Then I eat that one, or I throw it away, or I plant it. Then I reach back in. I'm going to pick the second seed. What's probably the next one is a strawberry seed now. How many strawberry seeds are there?
Wait, why are you talking about strawberries?
I'm sorry, cucumber.
Oh, 8 out of 25.
Strawberries are in my head. Cucumbers, there's 8 cucumber seeds out of 25. Big ass, right? This is an illustration of this formula right here. Actually, this one. So probably watermelon and cucumber is the probably watermelon, bam, times the probably cucumber given watermelon, bam. Do you all agree that is not the probability of cucumber just by itself? What's the probability I pick a cucumber seed?
8 out of
8
8 out of 26. That is not what that is.
Also-
That is the probability of cucumber given. So this is probably watermelon
We've already done the given part.
times probably a cucumber given watermelon. Given that I just picked a watermelon seed and planted it, what's probably I pick a cucumber seed now? It's changed. You guys see that? Yes.
I totally see that, but it's weird how if we grab 2 seeds at once.
Oh,
probably
not at
the-
once.
Yeah, this is. It totally
Well,
changes.
even at once, which gets a little strange.
Yeah, if you
Right.
grab 2 at once.
Then it doesn't matter which way you set the equation up, to be honest. I
Yeah.
could put the cucumber first.
Yeah, because then
Yeah,
it would be
yeah,
like
yeah.
the same. That's just.
But the minute I pick 2 seeds, you could argue one of them was first and then it decreased the probability for the other
Yeah.
one. So it's a little weird if you do, so you do one and then the other one, makes it a little bit easier. Yeah.
So when you have 2 variables like that, that's going to be the AND formula?
No, yeah. I like to write it like this, but for now, let me just do this. So later you're gonna see, it's a nice way to kind of do it if I'm gonna pick multiple things, right? In fact, let's do one of those right now. What if I pick 5 seeds, that's a 5, make it 4, pick 4 seeds, and I want to know the probability to get watermelon, strawberry, cucumber. Whisk.
Are those?
Wait, starting from 25 to 26.
I want to know the probability I get a watermelon, and then a strawberry, and then a strawberry, and then a cucumber.
Without replacement?
Yeah, this is all without replacement, right? All the same problem. So this is resetting things, right? This did not happen up here. I
Oh,
always
it
get
didn't
some-
happen.
No. It's always a reset. What if instead I wanted to get this? What's probably the first one's a watermelon?
11 over 26.
Yeah, then I plant that one. What's probably the next one's a strawberry?
7 over 25.
So then 25.
Or 7.
I plant that one. It's probably the next one's strawberry.
What's
6
7
over
over
24.
24?
Not 7.
6.
6.
Oh.
Didn't I just lose the strawberry?
That's right.
Is everybody with me? Why is the bottom always going down by 1?
Because
You're without replacement.
I'm losing seeds. The bottom is just seeds. Why does the top only sometimes go down by 1 from what it was?
The type is.
Because it depends on if I actually picked one of those, right? Why was this still all 7 strawberry seeds? Because I didn't pick a strawberry seed yet. Why is this 6 now? Because I just picked one and planted the damn thing. Do you guys see that? And of course, the last thing would be,
8 out of
yeah, still got all 8 cucumbers, but I only have
23.
23 seeds, and then whatever the hell that is. You can tell I'm very concerned about the answer right now. throw it in a calculator, you get a decimal, don't you? It's amazing, okay. Well, out of curiosity, did anybody do this one?
13.538.
13.54%?
0.538%. Yeah.
Okay. And let's see what we get here.
Oh, at the bottom, I got, you want the decimal or the percentage?
2.8, 13. I want the percentage. Wait a second.
For the big fraction, I did that already.
Shoot, I don't know what the hell it is. What
It
is
is
it?
the percentage?
The decimal's fine.
Decimal 0.0103, and there's more stuff behind that if you want.
Is that rounded correctly?
4 decimal places, yes.
Okay. And then you can make that 1.03% if you want to. Is everybody with me? That last part was not interesting. You just throw in the calculator, right? Okay. Does everybody really get this? This is actually kind of nice if you let it be. So if I say without replacement, they are always, the bottom at least is gonna change every time, because each time you're losing, so you just lost something. I always get somebody change the bottom by more than 1. That will never happen, because what does this place represent? I picked 1 seed so far, so there's no way the bottom can change by more than 1. It
It's like
cannot,
one
because I'm
seed
doing
exactly.
1 at a time. You with me? All right. Does that make sense? Yes.
So does the given, in this instance, the given mechanic where
Yes.
C with cucumber with with watermelon.
Given that watermelon,
Yeah, that's eliminating the numerator, right? That's
that is what changed the denominator here.
Oh yeah. Okay.
Yeah. That's really why this probability is not equal to the probability of cucumber for the beginning. They're not equal to each other. Because it's changed because something happened that changed it. I picked a seed already.
I thought you said that was because it's we're doing without replacement.
Yeah, exactly. If I had
Oh,
done
that's-
with replacement, nothing would have changed.
And that's
Yeah.
It's a little bit confusing by the given.
If without replacement is the probability of A and B, would with replacement be the probability?
No. Okay. With replacement, these same questions. So if I do this with replacement, nothing changes. So real quick, can somebody just run down for me? What's the probability of W?
It's gonna be 11 out of 26.
11 out of 26. What's probably of S?
7 out of 26.
And
And 8 out of 26.
Yeah. Okay. You guys all with me?
Yeah.
Jeff graded too many things this weekend. I think I'm really
It would be the same problem, it's just the numerator would change, but the denominator wouldn't, because now you have replacement.
Okay, not much. So if I redo the first question, if I'm doing with replacement, what does with replacement mean?
Put it back.
I put the damn seed back. I go, no, I don't want to plant it. You plop. The little seed's like, I want to realize my potential. No. Probability of W and C is literally just going to be this times this, because they're independent now. If I drop the seed back in, doesn't everything reset? No next thing is dependent on what I just did, because I reset the damn thing, yes? So this is just gonna be W, drop it back in, C. And then whatever the hell that is.
That turns it into the and. Okay, I see that.
Yeah, these are the same formula, it's just that the second guy will change if you change the situation. So if I do it without replacement, I've changed the denominator. I don't have the same number of seeds in there.
It's 13.018%. That's rounded.
And see, did that change much? Not a ton, but still an appreciable amount. Yeah, okay. You guys semi with me? Is there any semi? Please let this be nice. This idea of just multiply. If I got 2 seeds, I'm gonna have 2 probabilities. I'm gonna multiply because and. Does this change? Well, is it with replacement or without replacement? That's the thing. So what would the next one look like if I did it with replacement? WSSC.
11 out of 26.
W
Times 7
Out of 26.
S
times 7 out of 26.
S.
Times 8 out of 26.
C, yes. See, the with replacement's easy as shit. You just have to use exactly the probabilities. So if the situation is independent, I could just multiply the probabilities I have. without thinking. Why is this independent? Because if I drop the seed back in, everything's reset. I haven't changed any future probabilities. If I take a seed and don't put it back, I've now changed the situation. Future probabilities are going to be different because I have less seeds.
Got the answer if you want to do the comparison.
Oh, sure.
0.0094.
Nice. So under 1%, just over 1%. Okay. Are you guys with me? I like it. Okay. Cool. Fine. So the next kind of level of this, can somebody tell me how big is the population we're dealing with in this problem? Yeah. So if I pick 2 seeds, that is 2 out of 26. That's a pretty decent chunk of the population I'm taking at a time. Does everybody agree? You guys understand? That's roughly 8% of the population every time I'm taking something. You guys semi with me? Okay. So, watch this. Here's where things get a little different. Okay, everything's gonna go away. So what if now I said, what are you gonna say, Jeff? Let's find out. Let's say that 14% of STAT students love calculating standard deviations. So let's call this probability of L, right? What's probably somebody does not love?
86.
80.86, I love it. So this will be 0.14 for loves it, 0.86 for doesn't love it. By the way, what's the population here?
26.
STAT students. And let me just make it in America, right? We won't go for the world. How many STAT students do you think there are in America? Quite a few. It's a huge freaking population, right? Let's just say there's 2 million people taking some kind of statistics. You guys with me? I don't know. Sounds good. Like all stats I just made up. Not true. So there's 2 million, right? And 14%, let's see if you guys are cool with this. 14% of 2 million would be roughly, 280,000, is that right? 14%, 1, 2, 1, 2, 3, 4. Yeah, okay. So just stay with me now, stay with me. This is not anything you're gonna have to do. Not direct. I wanna show you why what we're actually gonna do is stupid easy. We have to understand why we're allowed to do it. So if I picked 2 people, and I wanna know is probably that both of them love it. Love and love. I do not have to do 280,000 out of 2 million times 279,999 out of 1,999,990. I do not have to do that shit. Somebody help me out, please. Verify 280,000 divided by 2 million is 14%. It is. It is, of course it is. So that's what we got. Can somebody please do this division for me? Somebody please divide these 2 things. Does everybody understand what just happened? If I'm on a probability 2 people love statistics, this is the way we would do it if we did it like we just did. I do not have to do this shit, and we're about to see why.
0.1.
Do it again, sorry. Do it again. 1.13. 999. 57. Wouldn't most of us call that 14%?
Wait, you're
Yes.
talking about 2 people or 1?
2 people, sorry. So 2 people love and love.
Oh, because it's so minuscule you don't want to even deal with it?
Yes, so when our population is huge, and how do I know if it's gonna be huge? If I say 7% of Americans like lima beans or something. That's a huge population, yes? How many Americans are there? Do you guys even know? It's like, do I know?
Documented.
It's like 340 million. Yeah.
Ish.
Yeah.
Documented.
Yes.
A lot more than that.
By the way, everybody pays taxes, even if they're not. Okay. But no politics here, no politics.
Sorry.
No, you're good, you're fine.
Population's much bigger.
I know. The actual population of people in the States is much bigger than what we know. So here's how I would actually do this problem. And it just erased the important thing. So probability of L is 0.14, yes? Probability of not liking it is 0.86. And everybody's cool with that, yes? Because they have to add to be 1. So if I said was probably to get 2 that love it, I would just do 0.14 times 0.14. Since it's such a large population, like somebody said, the change would be so minuscule, there's no reason to do out of some huge thing and then take it down by 1. The math is just gonna laugh and it's like, all right, if you want to, human. So this kicks ass, because what if I wanted to have like the first 5 people love it and the last 7 people don't? Watch what I could do. I could do, how many 0.14s am I gonna have? 5 of them. How many 0.86s am I gonna have? 7, and then I can just throw all that in the calculator. So when I'm dealing with a large population, I don't have to change the probabilities, even though it's not independent. I don't want to pick the same person twice here, correct?
Mhm.
Now, to be honest, in the future, we're gonna assume we could pick the same person twice. But right now, we're gonna assume we don't want to. But the reason I don't have to do like we do with a smaller population, like these seeds in a hat, is because a change of 1 doesn't do shit. Right? Okay. Yes.
And that still applies there, because even though you're picking 12 people instead of 2, it's still 12 people out of millions, so it's.
Well, the population I'm picking from is the millions.
That's right, yes.
12 doesn't matter.
I'm saying you're picking 12 people, I don't know if it's with replacement or not, but because it's out of, even though it's 12, which is more than 2, it's still such a small number compared to the millions that it's fine.
Yeah, the important thing is the 2 million.
Mhm.
Yeah. Okay, so, with all that in mind, let me give you this. See how we do. I'm gonna put you guys in groups. Let's see, I might get my fingerprints all over this, but too bad. One of the sides says this side in class. That's kind of a giveaway. The other side is the practice quiz, which I'll have an answer key for. What's today, Monday? This Wednesday?
Yeah. Oh.
Yeah.
In stats, is there a arbitrary safe guideline for what is considered a huge population?
No.
Almost. Yes. Here's where the thing, if the number of things we're picking is less than 5% of the actual group we're picking from the population, then you don't have to worry about changing things. So, I'm gonna put you in groups. I'm not gonna do what I was about to do. I was about to do a little 1, 2, 3 thing. Then I'd make you guys hate me even more than you already do. So let's just, can you please, your guy, help me? Get together with 2 people near you, right? Make little groups of 3, maybe 4. I know some of you guys like to make a mega group. Maybe try to keep it down to 2 or 3, right? You can do this, you can do this.
How many?
You don't have to talk to me, just turn your chair and make me feel good. This one.
I know we had a great time. We had much work done.
If you gave back your calculator and you want it back, you can check it back out.
Yeah, no, I got 0.7159.
All Alright.
Wait, hold on.
Because you're replacing, you're pulling one out, putting one back in, pulling one out.
Why would you set it when it's seven?
Because
Remember,
you're replacing it.
I know, but it says you are doing just like two Democrats.
You don't round from a zero up. If we're doing 4 decimal places, you would use the 5th decimal place, and like the 4th. Well, the 5th decimal place is a 0.
It means like you're drawing like
Yeah.
But why seven?
two chemicals.
Why 7? Because this is, because there's 7 Democrats.
Professor, I didn't get very far. I'm gonna need your help with that. Letter F.
Alright, guys.
I feel like we're telling her all this and we're
Guys.
No, right? We're going in circles.
Guys and girls and everybody.
You guys figure it out?
Okay.
Oh, yeah.
we're just going with it. I've used my last
What's
brain.
funny is because they cancel out, you're gonna get the same answer.
Nick, you're doing the denominator changes.
Yeah,
Without replacement, you're.
I know, but this one is with replacement.
I'm talking about.
Without replacement, which is 6 over 20 times 7 over 20.
Yeah. Alright.
Maybe
Guys. Everybody.
Because we took it out of simple.
Why not 1%?
It's my turn to talk. Alright. So the very first question, nice. Yes, nice. And these are always completely separate questions. You all understand. So it kind of resets. I had somebody asking if this changed this. No. They're separate questions. So if I pick one person, probably they attend Grossmont, is what?
126.
Yeah, and that is the fundamental idea of probability. It's the number that matches what I'm looking for divided by the total number it could be. The total could always be 176 for this problem unless I give you information about the person. If I don't give you any information about the person I picked, it could be any of the 176. Does that make sense? So for a given probability, the bottom will change because I'm throwing some people out of consideration. What'd you guys get for this?
0.7159.
Sounds right. And you can make that percentage if you want to, blah, blah, blah. Same problem you had, business major, equally easy.
92 over 176.
92 out of 176, and you get
0.5227.
5227, is that what you guys got? Okay. Here's your first real challenge. And the way I would do this, don't use the formula. You can, of course, it'll work. But if you count the Grossmont students, that's 126. I also need the computer science majors. How many computer science majors have I not counted? 11. That's 137 out of 176. Now, if you do the formula, it'll be 126 plus 73 minus 62. Well, 73 minus 62 is freaking 11. So it's mathematically, it's the same stuff. Do you guys understand? Maybe, okay. What's this? I almost don't care about it. Let's do it. 77 what?
84.
7784?
Yeah.
Okay. And always trips people up. And it's the easiest question, right? If you try to use a formula on this one, holy shit, it's going to be horrendous. I don't need a formula. I do not need a formula. How many people are math majors and Cuyamaca students? There's very few. There's only 2 people that are majoring in math and they're going to Cuyamaca. Remember what's the other name for and? Intersection. So 2 is where they intersect. That kicks so much ass. Do I know anything about the person? No. So it's out of 176 and whatever the hell that is. What do you guys?
0.0114.
0114?
Yeah.
Okay. And you can make a percentage if you want to, blah, blah, blah. Okay. So by the way, work, answer. You can make a percentage if you want. Is that cool?
Yep.
If you just give me this, I'm going to take some points. If you give me this and it's wrong, you're losing all the points because I have no idea what you did. Does that make sense?
Yeah.
Okay. Work important. Okay. Given, bottom's going to change because now I know something. How many people could I possibly be talking about here? Because I'm given that they're computer science majors. So how many people could I? 73. Out of those 73, how many match?
62.
62. And what's that? 8493.
93.
Is that right?
Mhm.
Okay.
I'm I got the same answer, but I did the long formula way.
Neato. That'll work. It'll just take you a while. Okay. You guys all, I didn't have to use a single formula here, which again does not mean the formulas are worthless. Just formulas are important. They have their place though. So when you take algebra, you don't get to hear this very often. You don't need formulas all the damn time. Sometimes you can just figure it out, and that it still follows the formula, but it's just an easier specific instance. So in the cases where I give you everything you can count, screw the formulas. You can just count, because probability is based off of counts. So if I can count everything, I'm golden. Now, 2 of the problems I gave you were probabilities of Grossmont student. There are 2 of them. Which ones? The first one, obviously, yes. What else was the question about the probability of a Grossmont student? Yeah. So given their computer science major, the probability they're a Grossmont student is this. Is that different than just the probability they're a Grossmont student without knowing their major?
Yep.
Does everybody agree? It definitely changed. Here's probably their Grossmont student. Here's probably their Grossmont student. If I know their computer science major, it went up. But the important thing is it changed. You with me? So what is the probability they're a Grossmont student? Doesn't it depend on if I know their computer science major?
Yeah.
So they're dependent. These numbers changed. So how do I answer this question for my freaking picky ass stats teacher? Well, I do this. So the probability of Grossmont does not equal the probability of Grossmont given computer science. 0.7159 does not equal 0.8493. Dependent.
Okay.
How many words did I just use in that answer?
1.
If you catch yourself, when I'm asking you, are these independent? If you catch yourself writing a lot of words, you are wrong. Erase. You can't say, well, some of them are, some of the Grossmont students are going. No, nope. This is a mathematical idea, right? Does everybody understand what I'm saying? So if I ask you, are these 2 independent, and you start to write me a paragraph, you're wrong. You're wrong. And I'm not being mean. Hopefully you guys understand. Oh, you're wrong. Don't even try it. No. This is a mathematical idea. I have to investigate this. Okay. All right. Number 2. I let us all live out of fantasy. I'm sure we all want to throw some politicians, maybe in worse places than a haunted house. But nice thing is on part A, we get to put them back in. So 7 Democrats, 12 Republicans, 2 independents locked in a haunted house. We pick 1 person at random from the house. Find the probability that. So the first part is just 1, just to make sure you guys remember just basics of probability. So the first 2 questions are really simple. What's probably that 1 person is a Democrat? How many are Democrats?
7 out of 21.
Yeah, 7 out of 21, which is
0.33333.
3, forever. Yeah, 1/3. Hello. Person is a Republican.
12 over 21.
12 over 21.
5714.
5714?
Yeah.
Okay. All right, so that's nice. When I'm picking one thing, kicks ass. When I start picking more than one thing, shit. So this is, I pick somebody, they come out, they're like, thank you, and then I push them back in. Right?
You move it up just.
Sure. Oh, down. All right. So I have 2 people, and I see an and. I'm going to immediately put a blank space times blank space. And means multiply. And now I just got to figure out the probabilities for each pick that I'm doing. So the first one is an independent. What's the probability of that?
2 over 21.
Good. 2 independents out of 21 people. They're thank you, and I shove them back in. The next one is a Republican.
12 over 21.
12 out of 21. Because I put it back in, so everything resets, right?
Mm-hmm.
So what's that?
0.0544.
Okay. Now, real quick, I'm going to do the one below that real quick because it's the same question,
Yeah.
but this is without replacement. What would change? The first one is an independent.
12
Nothing's
over
happened yet,
21.
so it's still 2 out of 21. But then I let them go, right? I'm like, it's fine. Get out of here.
It'll be 12 over 20.
Good. What's the next problem? Being a Republican? There's still 12 Republicans in the damn house, but now there's only 20 people in the house, right? And then, whatever the hell that is.
0571.
0571?
Yeah.
Okay. Let me stop for a minute. You guys see that? Same question, but different circumstances, right? If I put them back in, the bottom resets. If I let them go, the bottom doesn't. Why didn't the top change? Because all the Republicans are still in there. It was an independent I let go. Next question, 2 Democrats, which another way to say that is Democrat and Democrat.
Yeah, be 7 over 21 times 7.
Yeah, so 7 out of 21, throw them back in the house, 7 out of 21.
This guy gets it.
What's up?
That's where I'm a little bit confused. Why would it not be 1 over 21 because you're selecting 2 total? Like, I don't understand why it's 7.
What's the probability that the first person I pick is a Democrat?
7 out of 21.
I throw them back in the house. What's the probability I pick a Democrat now?
It's the same.
7 out of 21. Yeah. You guys okay? Real quick, do you understand if a person said the probability of a Democrat is 1 out of 7? What is that person thinking? They are completely wrong.
It would just be Democrat.
If they said this probability is 1 out of 7, what are they thinking?
Oh, that the total was 7.
So they're like, I'm picking 1 Democrat out of 7. But if I just said what's probably to pick a Democrat, that is so not. If I would have said, what's the probability you pick Bob the Democrat
Oh,
out of the Democrats?
that's 1 of 7.
That would be 1 out of
Unless
7.
there's 2 Bobs.
Because I know something. I know I'm picking out a Democrat, so I know the bottom 7. If I just say what's probably to pick a Democrat, it's the total number of things that are Democrats divided by the total number of things. Right? I'm going to call them people. I'm sorry. They're people.
That's okay.
For a moment, they were things. So, are you guys okay? Sometimes I don't want to point out mistakes people make because then people start to think it's the right way. Is everybody cool with this one?
Yeah.
Did I do that right? I guess so. Okay. This one? Okay. Now, if I do it without replacement, I pick a Democrat and I let them leave. Good Lord, Jeff. What's probably for the next one?
6.
Yeah, I got 1 less Democrat, 1 less person. 11. And that'll be 0.1,
1000.
yes. 10%. Okay. All right. How are we doing so far? All right. Okay. Bunch of con A's out there. Now let's start with this one. Very quickly, this is a true story, but the way the survey was worded, you can't infer this. The thing though is it's more than 0% of people that believe this. But let's just go with this. This is what was reported. Let's just go with this. So let's say 7% of people do actually believe that chocolate milk comes from brown cows.
I heard it was a watch.
I know when I was a little kid I thought so.
Yeah.
There was a commercial with a little brown cow and the guy and there's some chocolate milk and I'm like, oh, chocolate milk comes from brown cow. I was 4, so I was allowed to think that.
When
So-
I was a kid, I liked strawberry milk, so that one threw me off. I was like, there's no pink cows.
Yeah, where are the pink cows, man?
That's
Man,
okay. People
they're keeping those hidden.
more times
Yeah.
as well.
They're like, these are special.
Everything's enhanced.
Yeah.
Green chickens and green pigs.
So let me
If
see
your
if you
chickens and
guys.
pigs are green, I've got bad news. They have botulism. Don't eat them.
Oh.
So guys,
Anyway.
let's keep the botulism talk to a minimum.
You're gonna get sick.
Guys. So guys, let's pick a variable for things that chocolate milk comes from brown cows.
Stupid.
What letter
S.
do you want to use for that?
S for stupid.
S for stupid, is that right?
No, that's stupid.
T for true.
Wait, no, please do it. Like,
M.
B for brown.
B for brown.
B for
okay.
brown, all right.
I was waiting for something that actually made sense. Okay. All right. What's the probability that they don't think that then?
0.3.
0.93.
0.93.
Oh,
Yeah.
yeah.
Okay. So I want to know the probability that, and I'm picking how many Americans? 4. So I'm going to have 4 blank spots. The first one thinks what?
Oh, is this gonna be like the one that we just did over here?
Totally.
Oh, okay. So
Could be a reason why I did it. How large is our population? How large is it?
all Americans.
Massive.
It's massive. So I don't have to do like this. I don't have to do this. Because how big was this population?
Small.
Tiny. So I have to do this because the actual changing the numbers actually changed it by you. Now I know you guys wouldn't think this is huge, but if you work with statistics and probability, this is actually pretty big. This switch here. Okay.
Oh,
So
that's why
look
they
at-
don't tell us with or without replacement. It's so massive.
Exactly. It doesn't matter. So the first probability is related to somebody who thinks this way. So what do I put here?
0.07.
0.07. The other three don't think that way. So what do they get?
0.93.
93, 93, 93. So if you just throw that in the old calculator, and some of you guys might notice you can put 0.07 times 0.93 to the third power, right? Good old algebra. What's 0.93 times 0.93 times 0.93? It's 0.93 to the third power. But do you have to do that? No. I'm going to do it anyway right now. 0.07 times 0.93 to the third power. What do you guys get when you do that?
0.0563.
0563, it sounds about right. All right. Now, everybody's favorite question. Now, let me get you guys to realize what it takes to answer this question. At least one. If I said at least one person in here likes my shoes, how would you show I'm wrong? Which effectively would be the opposite of what, if you can show me the opposite of what I said is true, that means I'm wrong. So if I said at least one person here likes my shoes, how would you show me I'm wrong?
That nobody likes your shoes.
Yeah.
Nobody likes my shoes. So what's the opposite of at least one?
No.
None. If the probably is going to rain today
Or
was
what
10,
about half? You can't have a person.
if the probably is going to rain today is 10%, what's probably is not going to rain?
90%.
Holy shit! So how do opposite probabilities work? One is one minus the other one, correct?
Mhm.
So everybody with me?
No.
If the probably is going to rain today is 10%,
Okay.
what's probably is not going to rain? So how do opposite probabilities work? One is one minus the other. How did you get 90? You did 100% minus 10%, correct? So if two probabilities are opposite of each other, one is one minus the other. Well, sort of, they're, of course, they're dependent on each other because they are each other in a way. Yeah.
It's probably the wrong time to say this, but we're never going to have a probability that's less than 0 or more than 100%.
No, that would be impossible.
That's,
Yeah. So when you say I'm giving it 120%, that's a psychological thing, not a true thing. Yeah. I'm reaching from a parallel universe.
yeah, but that's actually to answer her question. That's the same thing. It's basically it's going to be out of 100, so
Yeah.
that's how you get the 2.
Yeah. So two things that are opposite together take care of all the possibilities. Does everybody agree with me? Yes, maybe, no, whatever you just said.
Beautiful.
So if the probability that tomorrow that I get into a car accident is 1%, let's probably don't get into a car
99% chance.
99%. So how the opposite probabilities work? They both add to 1, or 1 is 1 minus the other one. Right? Is it very cool the fact that I just said 1? 1 is 100%?
Yeah.
Yes.
Okay. What does that have to do with this, Jeff? Well, if I wanted to calculate that, and I keep pointing there, I'm sorry, because I can see that you. If I wanted to calculate this probability directly, that would so desperately suck. What does at least one mean directly? I have 4 people. I want at least one of them. What does that mean?
At least one.
Shh, great.
Oh,
What does it mean?
One person.
It could be 1. It could be the first one, or the second one, or the third one, or the fourth one. That's 4 problems so far that I have to calculate and add. What else could at least one mean? 2 of them, yes? Could it be? It could be the first 2, or the last 2, or the middle 2, or the first one and the third one, or the second one and the fourth one. You'd have to do all those probabilities and add them all up. You with me?
Yeah.
Or it could be 3 people, the first 3 or the last 3, right? Or this one and these 2, or this one and these 2. You guys kind of with me? You with me? Now some of you guys have tuned me out because you're like, I don't give a shit. I ain't doing all that. I ain't doing all that either. Because we're going to be smart. We're going to go, that question sucks ass. And we're going to say, what is the opposite of at least 1? What did we just say? None. So if I can figure out the probability that none of them think that way and do 1 minus that, I've answered that question. I need you all to understand.
You're doing that.
The probability of at least 1 has way too many possibilities. I'd have to calculate each one of those and add them together to get the total probability. That would so suck. And I've only got 4 people here. Imagine if I had 80. Yeah, that would be a lot. So, if I can calculate, basically answer the opposite question, what's the probability that none of them think that way? I don't want any of them to think that chocolate milk comes from brown cows. So what's going to go in each spot?
0.93.
Yes, this one doesn't think that way, this one doesn't think that way. Okay. I'm going to get that answer, and that is the opposite of what the question was. So the little question's all angry at me, but then I just do 1 minus that. What is, let's see, that's 0.8, 0.7, 0.6, I'd say 0.67? I don't know. It's a guess. Help me out, somebody help me. Save me from myself.
0.748.
Darn it. Okay,
One.
7, 4,
81.
8, 1.
That's right.
Does everybody agree that that is not the answer to the question?
Yes.
And you're all like, thank you, Jeff. What a great teacher. He has led us all to the wrong answer. But if I just do 1 minus this, that is 1 minus the probability of none. And again, you guys told me the probability of none is the opposite of the probability of at least 1. So if I do 1 minus that, I'll answer the question. Much quicker than if I try to do it directly. Because again, I don't know if you guys are really with me. If I have 4 people, and I want at least one of you guys to think something, could be you, or you, or you, or you. That's 4 problems already. Probably the first guy, probably the second guy, probably the third guy, probably the fourth guy. Or it could be you two, that's a problem. Or it could be you two, 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 or it could be you three, or you three, or you two and you, holy shit!
There's an infinite amount of
You guys, that's a lot. I don't want to do that. Do you want to do it? If you want to do it, you could do it on, another piece too. I'd much rather. So any time in the universe that the opposite probability question is quicker, I'm doing that. Because then I could just do 1 minus that and answer the question. Yeah.
My brain's probably working differently, but the way I think of that is like, it's another way of doing the process of elimination, kind of. Because we're like, hey, there's way too many possibilities here. Let's do something that's a lot simpler.
Yeah.
Eliminate it, and whatever's left must be that other answer.
And here's real quick. Here's another way to look at this. Go ahead. What you got?
If it was at least 2, would you want to do the same thing, but 2 minus?
Oh, at least 2 would be 1 minus none or 1. So you have to do probably none, probably 1, and you can do 1 minus that. So, watch this, guys. There are 4 people here, right?
Yeah.
How many could think a certain way? None of them? 1 of them? 2 of them? 3 of them? 4 of them? Yes?
Yes.
At least 1 would mean add these up, correct?
Yep.
All the probabilities have to add to be what?
1.
1. So if I want to know the answer to this, that would be the probability of 1 plus the probability of 2 plus the probability of 3 plus the probability of 4. Well, if the probability of all of them add up to be 1, what's 1 minus the probability of none? It's equal to this shit. Isn't that at least 1?
Yeah.
1 minus 1 chunk will be the other chunk. So I could just do 1 minus this little tiny chunk, and they will equal the other chunk. That is an awesome shortcut, if you let it be. Let it be. Okay. All right. So that happens a lot. At least 1 is one of the most reoccurring probability questions that happens. Because how do I check that an assembly line is working? I check a certain sample, and if at least one of them is not working, if at least one of them is defective, I stop everything and I'm like, okay, what the hell? So I want to know what's the probability that at least one of them would be defective. Let's do this last one. We got like no time left, which is great. We've already established that the probability of people that think that chocolate milk comes from brown cows is 0.07. What's the other thing I've introduced in this?
Lima beans. That's
Lima beans. So we'll call that probability of L. That makes sense. So what else? What is this? What is this 4%? Using the symbols I just picked. What's this 4%?
of Americans that think chocolate milk comes from brown cows and lima beans.
So how would I write that just in symbols?
B and L.
B and L. That's 0.04, correct? Now what's the question in symbols?
Find the probability that an American likes lima beans, given that they think that.
So what are the symbols?
L given.
L line B. And what's the formula for L given B?
Probability of L and B divided by probability of B.
Do I know the probability of L and B?
No.
Yes, I do.
Well, you do.
Because it's the same as B and L, correct?
Yeah.
Bob and Larry? Larry and Bob. Same damn people, right? So 0.04 on the top. And what's probably B? 0.07. You guys kind of with me? There are two problems in the homework where it's basically like this. And they're kind of nice because they actually give you the symbols for the situations. You collect the probabilities they tell you, and then you write the formula for the probabilities they ask you about. And then you just plug stuff in the right place. Oh my God! Okay, that's enough. Sorry. I'm just feeling okay. So don't forget, next time we'll start with the probability quiz. Next time is the review for the probability quiz. I'll have the answer key for the practice quiz on the other side. You guys with me? And then we'll also get into chapter 4 a little bit. Don't forget your IDs. Are you staying after class a little bit? Only as long as it takes me to pack up.